Okay, so hi everyone. Good evening. A very welcome to everyone who's in attendance today. Welcome to the day three, the grand finale of NASA International Space Apps Challenge Limerick 2021. Today is the third day of the hackathon, and this is a huge welcome to everyone again. We had the 3 days as divided like this. There was an opening ceremony on day one where we had a hack fest explaining the challenges. Then we had a pitch fest where different teams or different participants came up to the stage and pitched their ideas and their approaches on a particular NASA problem statement. And this is how networking started on day one. And then there were ice breaking sessions. There were multiple people going into smaller rooms talking to each other. They did not know each other, and then this is how networking began. This is how team formation took place on day one. So day one was all about networking. Day two, we had many mentors come in. So there were different mentors who were available to the participants for giving some feedback on their projects. And these mentors were subject matter experts, like you would know by now. And some of the mentors are today invited to this meeting, and we are honored to have everyone today joining us. Okay, so today is day three, and what are we going? What did we do today? The teams were asked to submit their team names or the list, the final lists, this morning by 6 a.m. And after submitting, we were able to plan out this presentation schedule, and each of the team was given a specific schedule. Then they were asked to submit their draft versions of their presentations, the PDF, which they're going to deliver to the judges now. And they were given a chance to present it to a mock judge, and we gave them feedback. So active feedback was given to these teams, and these teams then finally prepared their presentations by around 1 p.m. And now they'll be presenting it to the judges in the next 3 minutes. So in the next 3 minutes, we'll be starting with the final presentations, and one by one, each of the team will be presenting, and they'll be getting a chance to show off their work, the work which they've put in for these 48 hours, or I would say these 35 to 36 past hours. So the final presentations would go on from 3:05 to roughly around 4:15, and then we'll be having the results and the closing ceremony. We'll be having like a 5-minute break where judges can deliberate and they can talk about who is going to win this competition, and we'll be announcing the results soon. So there is like this was the schedule for today. And now the judging criteria. So what is the judging criteria? As we know that there are different NASA space apps challenges, complicated ones, and the judges are going to analyze on the basis of certain parameters. This was already informed to all the participants in day one and day two. Judges are going to judge on the basis of impact, the validity, the relevance of the idea, which or the approach the participant has taken, the creativity which is displayed in their projects, and their presentation in the end. So that's the judging criteria. And to introduce the judges, we have them on the call, and we're really honored to have you, Dr. James Patton, Dr. Nikolov, and Professor Mike Hinchy. We're really honored to have you as our judges for today, and I think they're on the call. I really welcome all of you on this panel, and the teams are very excited to show off their work to you. And okay, so these are the team presentations. Yeah, I think yes. Hi, James. Hi, Nikolov sir. Hi, Professor Hinchy. How are you? Great. So we have 7 to 8 teams who are scheduled to present, and let's start with the presentations. The first team which will be presenting today, the team which is presenting can take off their like put off the permission from their mics and their video cameras if they want, and you can present your teams. You can you can share your presentations, and all of the judges are going to evaluate on the basis of this. So the first team to go up is Team Green,
Yep.
and Mahir is there.
Yep. That's
Hi,
it.
Mahir.
What's going on, sir? Is
Okay,
it
so
fun watching on the screen?
whenever you're ready, you can start, Mahir, and it will be timed just so everyone knows. every team will be given a 10-minute slot. And Mahir, whenever you're ready, you can start.
Wait, a 10-minute slot? Okay. But the PDF.
10 minutes. But okay. So just an idea to give everyone. The delivery in a hackathon should be as small as possible, and you should give time for the question answers to the judges. So that's just a general recommendation. And 5 minutes, if you split it up, it would be good for you. But yeah, anyways, you can take it up. It's your project, and
Yeah,
go ahead. Best of luck.
Sure. My slides. I have like six. I updated the slides from my from the project pitch because you know how it said there's a 7 slide limit. So yeah, I'll just share my screen here. One sec. Screen here. Just a moment. Okay. Can everyone see my screen?
Yeah.
Yeah. Cool. Sure. I updated this from my project pitch. So hey everyone, my name is Mahir. I'm from Team Green of this challenge, and the challenge I'll be doing is unlocking the secrets of the sun. I addressed this on Friday or something, but I basically said the challenge is to increase awareness of all the exploration of the sun, the different spacecrafts and all that, and just how it affects our day-to-day lives. And an introduction to the project is we made an I'm the only one on my team, but I made an educational website using HTML, which my teacher, Mr. Sahir Sharma, taught me last year in first semester. And information of these spacecrafts is conveyed through text, images, and videos, and we hope that the website's detailed enough to be a useful resource, but simple enough to be accessible and entertaining enough for people of all ages and interests. Here's a snippet of the homepage we have. It's not super detailed, but you can see here it's just a quick introduction, and you have links to the various pages. And here's a snippet of the page of the Parker Solar Probe. You can see here I have a little image and a few fun facts about the thing. And we also embedded a few YouTube videos by NASA, and we also have for the other ones another solar prober. It's from the ESA, the European Space Agency. We also have a few videos from that, and that's pretty much all for the slides. I have the website here, so you can kind of see for solar probe. You can see here. Here's the page, and here's the stuff, and some embedded YouTube videos, and and you have a homepage to go back and check out the different sites for a thing. Like this one's on the solar orbiter and all that. So that's pretty much all I have to show for one. I was the only one on my team, and I was a bit busy with college work and stuff. So it's not like super detailed, but I think it's fairly decent. And also I had to kind of relearn HTML because I learned like once last year and made a website using that, then didn't really use it much again after that. But I hope that that's all right. That's all stuff.
We can ask questions.
Feel free to ask questions, and yep.
Okay, so Mahir, well done. And is this so? Why did you have to use HTML? Is one question, because these days you would use something like Drupal or other similar engine for constructing a website like that contains. So I saw that you collected a few videos, and
the first from
why not use a Drupal? Or I mean, that's the one that comes to my mind, and there are a few others that
I get what you're trying to say. Pretty much, I guess since I knew that there's kind of a time limit on this, and then there's also other stuff, I decided to use something I was kind of familiar with. And in first semester of first year last year, Mr. Sahir Sharma taught us HTML, and we made websites using that. So I figured that since I had a bit of experience, it would probably be best to use something I have a bit of familiarity with, rather than try and learn something completely new and try and build a website using that in the time. Like even now, even though I'm familiar with HTML, I pretty much had to like learn as I went, since we made that project in first semester, and then I didn't really. I was mostly just using Java and stuff after that. So yeah, I was kind of like learning the ropes again as I made the website, which is a bit tough on time, especially with other college work and me being the only one on the team and all that. So yeah, although I would have loved to have learned new technologies and made a website using that. It's just it would have been a bit tough on time.
Sorry, can I ask a question?
Yeah, sure, go ahead.
Yeah, so I suppose like would you say that the fact you had to work by yourself was challenging, like in terms of what were the challenges around that, other than just actually developing the content and stuff?
Yeah. I think the biggest well, for one thing, I'll say one of the reasons I decided to try and work alone is for one, I'm knowing that I'm not like super proficient in stuff. I didn't want to like bring any other people down. You know, I figured if I was going to do something that wasn't super great, I'd rather have it not affect others. But other than that, working on my own, I think the biggest issue was just, you know, the time constraints, trying to like learn everything like from scratch, pretty much from scratch again, and then you know, gather information that I thought was relevant to the topic. You know, unlocking the secrets of the sun and finding relevant information about like the space tropes that are you know, traveling the sun and all. And I had to do research about, because you know, when you look up the different spacecrafts that are exploring the sun, not all of them, like, you get results, but not all of them will show like ones that are like specifically exploring the sun. So you have to like filter through different information, see what would be most useful to people and what has where good resources are. Like, I mostly just use official websites like the NASA website and the ESA website, because I figured it you know, coming directly from the agencies, the information would be most reliable. So yeah, working on my own was a bit challenging, but you know, I think the product was fairly decent. I mean, yeah, it's all right, I'd say.
Oh, that's good. Thanks very much.
Cheers. Cheers. So,
Okay, so if there are no, are there any questions first of all? So anyone else?
yeah, anyone can feel free to ask. I don't know. No questions?
Okay, so the judges might just need a bit of time to enter in their observations, maybe,
Yep. Yep.
and we'll just announce the second team to go next, which
Yep.
is Team Space Bean Hunters. That's great, Maya. Thank you so much for presenting that. And
Yep, thanks so much.
let's go on to team number 2, which is Space Bean Hunters. Sean, Craig, Bartek, Masij, Patrick, and Pooja. Whenever you're ready, you can come to the screen. You can share your screens and set it up. And we'll take up the timer and we'll start a new timer. Yeah, and whenever you're ready, you can pop up your mics and just let us know, and we'll start the timer.
All right, can you see the screen?
Yeah, great.
Okay,
Great. Best
we're
of
ready.
luck.
So.
Yep.
All right, so we chose to do the challenge when light curves throw us curveballs. So the obvious place to start here is, of course, explaining the problem. Our asteroids can give us information about the universe we live in, but of course, we can't simply grab an asteroid from space and bring it to a lab or something like that to analyze it. So instead, one way to do it is to capture the light intensity we see as the asteroid rotates. And we can use that to plot the light level throughout the rotation to create a light curve, which gives us information about the asteroid, its shape, and its rotation. So our goal at this project is to create a tool that allows users to generate these light curves of a given shape and adjust the shape to show how the light curve changes based on that shape of the asteroid. So our approach is to allow the user to import an STL or object file and render that in 3D space. And then we will allow the user to morph that shape in any way to like scale it and resize it in any way. And then once they've chosen their parameters, the object will have a light pointed at it and it will rotate in place. Every frame, we're going to capture an image of that frame and add up the individual brightness of the pixels in the image. We'll use that to plot the light level of the asteroid at each rotation and use that to generate a light curve. And yeah, from there, the user will have the option to reshape the asteroid and run it again to show how changing the size of the asteroid and the shape will affect the light curve. So now we've got a demo from Magic. Sorry, Magic, is your mic working? Are you there?
Oh, sorry, I forgot to unmute. Thank you. Here we have a video of the software we have created. Once the app is launched, we are greeted with a menu to allow users to choose what shape they want to examine for its light curve. They can choose from a few example objects or they can import their own STL models using our GUI. This allows them to explore the light curve of any objects you wish to put into the simulation. After choosing the STL model, the simulation window opens up where you can see your selected object. We allow the users to change many variables, including modifying the shape of the object, changing its position relative to the sun, and its rotation. Lastly, you can specify how many rotations will be done before the graph is generated. The user can see as the object spins and the simulation ends. And after the simulation ends, the light graph is generated and compared with a previous graph. Next slide, please. Next slide, yeah. Here we can have a closer look on how we use the graphs to compare the effect of the shape on an object light curve. We use the Bennu asteroid model to generate the blue line on the graph on the left, and afterwards we change its shape, and after running the next simulation we receive the yellow line.
Again, sorry, Padraig, is your mic working?
Now it is, sorry about that. We generate a light curve using rendered images, which mimics the real physics behind the light curves of an asteroid. So long as the image is fully within the viewport, we generate a valid model. There are some limitations to this approach. We don't consider how the bodies move along their orbit when we're creating the light curve, nor do we consider effects such as the YORP effect, which is a result of thermal radiation due to sunlight, which might lead the asteroid to tumble in unpredictable ways.
This tool will cater to a variety of groups with its easy-to-use and simple UI. Here are some examples of the group we would envision availing of our program. Our primary targets would include the deep space mission team and the use of the software in educational contexts. The educational context could be from a primary school level to a tertiary level of education. Next slide, please. We are delighted with the progress of our project and found this competition to be a very enjoyable experience. For the future, we plan to improve on the current functionalities we have implemented while also adding new features. One example is to scale the camera more efficiently while importing objects, make the entire application live, showing full configuration and position of all the objects before the simulation starts to graph. We could also improve on the overall accuracy of the program simulation, taking into account factors that change the rotation so it's less predictable, like the planet's gravity and the effect of thermal radiation. Thanks very much for listening.
Okay, so I think the judges can have the floor for question and answers.
Do you want a question, Nick? Will I go ahead?
Please go ahead. Yeah, James.
Yeah, I thought it was really good. A nice looking piece of software as well you developed. So I was just wondering, when you actually started out, considering the idea, was there any kind of existing similar kind of applications or software? Or was it something like, you kind of conceived yourselves from scratch?
The only existing software that we were aware of was a web tool for the light curving of a binary star, I think, which is different to this software.
Okay. No, that's good. That's good. No, I was just wondering. Yeah, that's really it's impressive piece of software. Thanks.
Okay, I just wanted to ask you again, maybe ask something that you already said, but to repeat, what is a possible scenario of using the software? Can you describe one possible scenario?
Okay, so the light curve of an asteroid can be used to, from Earth, you can determine the rotation or roughly the shape of an asteroid, even though it may be millions or thousands of kilometers away. But from Earth, we only see this little dot of light.
Yeah.
So by checking the light level as it rotates, we can gather information, and by plotting that, we can determine more information about it. Just visualize it.
It's a good idea. Well done. Yeah. Okay.
Can I ask why you are morphing the images of the asteroids? What is the benefit of that?
That's a very, very simple and easy way of showing how the light curve would change with respect to, let's say, blemishes on the asteroid. Being able to warp the image in that fashion.
But why would you want to do that? Why would you need to know that?
I believe. Sorry. I believe.
Yeah, you go on. Sorry.
I believe this project is about showing the effect a shape can have on the object's light curve. So by allowing the user to morph the shape, we can get a clear comparison between the two light graphs. If let's say you just scale the object in one axis.
But why would that be a benefit? I mean, I've been examining asteroids for 20 years, and I just don't see what benefit I'm going to get from this.
It's not so much for something you already know about. Like this tool would be used to demonstrate a normal rotation of an asteroid, as opposed to a tumbling asteroid. Which is why we're kind of focusing on an educational context, because someone who wouldn't be familiar with that kind of, who wouldn't be familiar with orbiting asteroids, would like to see it in that way. Sorry if that makes sense.
Yeah, I just don't understand. I don't understand what benefit they get out of morphing it. Okay, fair enough.
I give you a more honest answer, I guess. The original challenge was to create a tool that allowed us to determine the effect of different asteroid shapes on the resulting light graph. So like none of us are experts in asteroids. None of us fully really know what the purpose of it is, but that was the challenge. That was what we were asked to create. So that's the reason why we did it.
Okay. So it's a bit of a little deviation from what the original plan was. Okay. Fine.
Okay, so are there any questions, sir? Anyone? Any questions? Okay, so the time allocated 10 minutes is up for team Space Bean Hunters, and thank you so much for presenting. Everyone. It was great and really cool project, honestly. Okay, so the next team which is up is team 3, which is Dream Team, and Anupriya Shanmugam is the member. So Anupriya, I hope you're on the call, and yeah, that's great. You can let us know whenever you're ready, and the time will start then.
Thank you, Sahir. Thank you for that. So yeah, hi all. I'm Anupriya, and today the challenge I took up was the lesson plan and bill of materials for developing a low-cost, high-altitude balloon. The object of my presentation would be like to help students understand what basically are HABs and give them the confidence to build. So at the end of the module, like they would have that confidence. They want to build a low-cost and long-range reach HABs. So yeah, my learning plan basically included like the introduction of HAB. So first of all, they should know what a HAB is and why they are, I mean, why do they even have to develop a HAB or something? And then I'm just touching upon the history of HAB so that they are like, they have an idea about from where it started and now where actually is, so that they know how the over time how it has developed, and give them a briefing about the HAB design. So this is basically about what a HAB is and what are the components it holds. And yeah, I've also included a few activities so that I can make the learning plan or the lesson plan a little interactive. So I've given them also a few activities. Also, I've given references, and I'm also giving them view of what materials can be used in HAB. And yeah, the end-to-end process in building a HAB also I'm giving them like so that they know like where to start and where to end. It's not like as soon as they hear the word HAB, they are lost. So I'm just giving them the end-to-end process. So where so they're confident that here, this is where we have to start. And once it's complete, yeah, it is done. So that one. And also I'm like to inculcate that confidence in them, I'm giving the factors that should be considered when developing, launching, and tracking a HAB. So mostly, yeah, weather conditions is something that I feel is more of a concern when you're trying to launch a HAB. So that is what I'm going to give them in this module. And the use of technology. So again, yeah, that's why I touch based upon the history. So in the past, how it was, in the present, how it is, in the future, how is it going to be? So that's all about this technology thing. And bill of materials, again, like from start to end, what are you using and how to calculate the cost, everything. I'm giving them a touch base on that also. And the final activity would be that now they have a general idea about it. So yeah, and the bill of materials, I've kept it very simple because it's like for basics, I've considered the basic students. So like I've kept it very simple. And yeah, again, talking about the activity 4, that would be the last activity at the end of the module. So they will have that confidence that they'll be able to build a low cost and long range HAB. So that would be the final module. So yeah, the learning plan will go like this. And I've just made one presentation of how the introduction would be. So it'll it'll have all the basic introductions, the uses and the types of HABs, so that they can decide on what kind of HAB they want, whether it's a conventional one or a long duration, etc. And I'm also giving them some stats taken from NASA space itself, like what are each and what is the use of it and how they can accommodate in their idea into this. And yeah, the construction and working of the balloons, how it happens, how do you construct from base to how it works and lands. And yeah, I'm also giving them an idea, like if you learn this, where you can implement it. So that is the learning by doing module. And this is like, finally, we are ending it like activity 1. So yeah, this I'm just giving them a general view of how to prepare a bill of materials if they're totally new to it. So previously I've given them just headings with that. Here I've just added a few things to be considered in their bill of materials. And also in case of they want, they're just worried about the cost effective thing. So I'm also giving a few pointers on how to reduce the cost. Like first thing they have to do is like, why are they developing a HAB? So the first thing is they should know like what is the purpose of developing a HAB. So in that case, they can reduce most of the costs. And then yeah, what kind of material they choose to use is again based on what type of model they want to build. And yeah, the technology, everything comes. So once they deeply analyze what they want to do and what is the purpose of the HAB, I think everything falls in place and a proper design would be given. And yeah, all my references were taken from the space apps resources and Googled a lot. And yeah, Wikipedia also I've taken a lot from there. So yeah, thank you for your time. And that's all from my end. So I'm open to any questions now.
Thanks. Sorry, what was the name again? Sorry, so here I'm just looking at my list, and I can't see.
Yeah, I don't have it in the list either.
Okay, so I think you need to add it.
Okay, add it. Fine, yeah.
Yes, I think
that's
there
perfect,
was a
yeah.
late some.
No, that's fine. It's just fine, just in case I got the name wrong. So I'll just add it to the list. That's good. Yeah. Okay.
It's a dream team, right?
Mm-hmm.
Yes.
Yeah, right. Yeah, it's a dream team.
Okay.
Sorry, I quick question with the. I think maybe I was reading it wrong. I think you had down somewhere. Was it $1,000? Was the cost?
Yeah, that was like I just saw on the internet, and the lowest cost till now achieved was $1,000. So this was done by the Stanford students, University of Stanford. So the lowest achieved was the $1,000. Sorry. Yeah. So actual cost till date, what was achieved is like $1,000 model was the lowest cost achieved.
So would it be kind of like if that was the cost, would it be kind of difficult for a lot of schools or educational things to have like kind of that level of budget to do this? Do you think?
So that's what I was telling about. Like, first of all, we have to decide like where do you like what is the purpose of your HAB. So based on that, if it's just for like photographing of the space or something like that, in that case you can reduce a lot. So if not, that's not the case. If you want a weather analysis something, so you have to send in sats. So when the weight is more, you have to include more of helium into the balloon so that it carries it to that level and then just bursts off. So again, it's all like what they want to build, and based on that, we can talk about the cost reduction. So everything is a basic thing, like what you want to build your HAB for. So you have to be very clear about why you're building a HAB. And then comes the cost, everything falls in place. The material, the cost, everything will fall in place.
Mm-hmm. Okay, thanks.
Thank you.
I have a question. So in terms of an app, I didn't fully understand. This is an educational app or what kind of app? It's
So Dr. Nikolov, just to budge in, really sorry. This CESIC challenge was to create a lesson plan for NASA. So it was a pedagogy-based challenge where a teaching plan was the product. The product was not an app, but a teaching plan. A teaching plan on HABs, which are high altitude balloons, which go up, and that was the challenge.
I understand. Okay, that's fine. Yeah.
It was just an exception because we in Space Apps, like we welcome all kinds, and teaching is something which was included specifically for this year's initiative. And that's why we had this challenge.
Okay.
Okay, any questions for Anupriya? Dream team? Anything else? Okay, so I'll just share my screen. We can shift from team 3. Thank you so much, Anupriya. That was great. Let's go on to team number 4. Lua Lipa +1. And the members are Aruna, Johnny, Mikey, Nutsa, and Rania. And they're working on the challenge, which is mapping space trash in real time. So that's the challenge which they're working on. And whenever you're on the call and whenever you're able to share your screen, just pop in the chat. We can start your timer. I hope you're on the call. Aruna is there. I see Aruna, John. Yeah, everyone is there. So whenever you're done, guys, you can share your screen. That's great. And I'll go off. You can tell us when to start and the timer will start.
Okay, can I share my screen? Okay, can you see this? Yeah, you can see. Okay, so this is the title of our project, Space Brewsker, and Brewsker basically just means rubbish in Irish. And is this working? Okay, so this is our team. So that's Nutsa, Mikey, Rania, Johnny, and me, Arona. We're all computer systems students at the University of Limerick, and we came together to do this project. So basically our challenge involved developing an open source geospatial application which displays and locates all current known space debris orbiting the Earth in real time. So the reason why our challenge is important is because the amount of debris orbiting the Earth is continuing to increase. And this will lead to a lot of issues down the line, such as access to space for future missions, which in turn will impact exploration and even routine aspect for our life on Earth. Some examples then of our stakeholders would be space agencies, space education institutions, and the International Space Station, because space debris causes an increased risk of collision with and damage to functioning satellites. A few facts then to highlight the essential nature of this project would be there's over 20,000 artificial objects in orbit above the Earth. There's 128 million pieces of debris smaller than 1 centimeter, 900,000 between 1 and 10 centimeters, and then 34,000 less than 10 centimeters. So then for the ISS in particular, a lot of debris, which can travel at approximately like 16,000 miles per hour in low Earth orbit, would pose a threat to both the spacecraft and the astronauts due to these speeds. So I saw recently in June of this year, the ISS, the Canadarm2, the robotic arm that they used there was struck by space debris, and it created a hole in it. And it didn't actually affect it, but the consequences could have been not only mission ending, but catastrophic for the astronauts that are there at the minute. So I guess the achievements with this project, we wanted to provide a pleasant UI for users to be able to view the extent of which space debris has essentially polluted our Earth's orbit. We wanted to shine a light for future generations so that they can care more about the consequences of what we have left behind in space, and hopefully increase collection of space debris. And then I guess hopefully once people are more aware, we can eliminate space debris as a factor considered for space travel and pollution alike before it becomes a real problem. So it's better to deal with it as soon as possible rather than let it become a problem. Then I guess our inspiration to choose this project revolved around, as well as hearing about the ISS in June and being advocates of the health of our planet, the interest in a data-related project and the project of mapping space debris seemed like a nice challenge. And when we were brainstorming and kind of looking at it together, trying to visualize it, it seemed pretty cool, like when we were trying to make it happen. So yeah, when we've also never done a hackathon before or any project as such, because it was very graphics heavy and we were up for a challenge and to learn new things. So yeah, that's it for me, and Ronnie will take it from here to talk more in detail kind of about the project itself as well as our future developments with it.
Thanks, Rona. So our solution to the challenge is a 3D globe that the user can move around and control with their mouse, and then have the debris represented as red dots around the globe. So a more detailed description of the project. So it works by displaying a 4K 3D globe in which the user can freely navigate and view all of the respective space debris locations represented by red dots. The data is read in the main.js file, and it's used then to plot these red dots above the Earth's surface. The file uses 3JS for creating the globe and its movement, and then for creating the red dots above the Earth. And then it also uses satellite.js for getting the position and the velocity of the debris, so we can accurately map the debris in real time. And finally, it makes use of the GLSL files that we created to create the shading and the atmosphere of the globe. So after a lot of teamwork and cumbersome data retrieval, we were able to produce a product that we're proud of at the end of these 48 hours. So our approach was as follows. So first we started off with our 48 hours just with research into technologies we should use and where we can get started and get our data from and how we would divide our work up. And then next, once our research was complete, we all synced up and discussed what we found and began assigning roles. Then we began with downloading the data into the format we needed. Then we moved on to implementing a plane sphere, which we later mapped a world onto. And then next we mapped a single red dot coordinate onto the globe and made sure that it took into account the altitude and hovered above the globe. You probably can't really see the one red dot in the photo. You'll just have to take our word for it that there is just one red dot in that picture. And then next on the agenda was to read in the data and have multiple red dots appearing in accordance with the data. So this sounds like it's a very straightforward and easy process. However, this is what caused us the most trouble, was getting the data in the right format and getting it onto the JS file. And finally, we focused on the appearance of the globe, adding shading elements to do our best to represent our world and its true beauty. The challenges we faced were getting the correct format of data, as I mentioned earlier, and also the lack of sleep didn't help. And another challenge was that most of us had never touched JavaScript before, so we had to pick up that language and then produce a viable product at the end of 48 hours. Finally, shading the globe and creating the atmosphere is more difficult than we anticipated also. How we solved these challenges was through a lot of Googling and then speaking to mentors and discussions with each other. So future developments, so what we would like to include as future development is the representation of the growth rate of space debris if it's left unchecked. So this involves some machine learning to plot some future data and then show everyone how important it is to act now, and also to provide more information of each red dot. So when a user would hover over it, we could have information like what kind of debris it is and how long it's been there, etc. And finally, just to have better graphics. So like when zooming into the globe, maybe a Google Earth kind of implementation where you can keep zooming into countries and cities, etc. So thank you for listening. Irona will give a small demo now of our project, and I'll send a link as well into the chat for you, and you can give it a go as well.
Thank you, Rania. So yeah, basically here is the Earth. And we can see all the red dots which represent the space debris that are currently in space now. And if we zoom in slightly, we can see them moving slightly a bit there. So that's in real time. And if we zoom out as well, we can see how the Earth looks, and it was rendered well enough, I guess. And we can see the atmosphere as well. And if we zoom out far enough, we can see all of the debris that is being represented by the data and by the dots here. And yeah, you can play around with that by the link that Rania sent, and yeah, just move around and you can see everything there. And yeah, that's it, I think, from us. Thank you for listening, and we're open to any questions. So yeah, thank you.
Okay, that was great, Ilona, Anya. The judges can have the stage. Any questions?
I have a quick question. Yeah, it looks pretty good. So I suppose, would you see this as being like a kind of an educational tool to highlight the fact that there's that much stuff around, or would it be something that you'd see you could extend it to be like a kind of a tool that could be used, you know, at a level when you're planning and stuff, like, you know, if you were actually, you know, thinking about, you know, doing some kind of a space mission or something?
Yeah, for sure. It could be used for both aspects. Like, yeah.
Both aspects, yeah. You could, I guess, use it to raise awareness as well. Just if you are kind of going down the route where you want to tell people, look, stop doing this, or we need to solve this. But then also you could use it for safety for astronauts and stuff like that as well, and also satellites that aren't cheap that we're sending up there and stuff like that.
Yeah.
Like the extent of debris is crazy. Like even with the ISS like being hit, like that could have been a lot worse. So.
And all that. Again, I'm not really familiar with the information, but the plots and stuff. All that debris then it's all stationary, like geostationary or whatever. It's not like in a what's the word? Just an orbit that's.
No, it's moving.
Falling. It's all moving, so it's all on the way back.
Yeah, it's all on the way back. That's the issue as well. That's why they leave it out, because they're like, oh, it's going to come back and then it'll just disintegrate, like as it's coming back into the atmosphere. But that will happen, but it would take a really long time. And then some debris also floats out, so then that's going to affect people. Like say if they're going to Mars, like they could hit something on the way. So not the ideal.
Okay, that's good. Thanks very much. Thank you.
No worries.
Yeah, my comment is also that that looks like great work and well done. And I see that you put a lot of effort and you have a working prototype at the end, 48 hours. That's very impressive, very impressive.
Thank you.
So yeah, my question would be along the same lines as James. What would be the potentially how this can be even more useful than than only visualization? So yeah, I mean, you answered this well, so yeah, it's fine with me.
Thank you. That's great. Thank you.
Yeah.
Professor Hinchi, any questions for you?
No, I thought it was very good. Space debris is a huge problem, as you say, and it is a significant worry. Yeah, absolutely.
Thank you.
Very good.
Okay, so that's great work, Rania, Iruna, and team. And that's really good. Let's move on to the next team, which is there for presentation, and that's the team from TCD. So we have a team from TCD. Let's welcome us. Let's welcome them. And Soha, Khwahish, Fatma, Ashley, Taylor, and Dimitri. Whenever you're ready, please let us know, and we can start the timer. I think you are on the call. Yeah, I see you on the call. So great.
Okay, but can you see our screen?
Yes, it's visible. All good.
Okay, that's cool.
Okay, best of luck.
Okay, thank you. Magnets. People didn't know much about magnets before, so they just thought and assumed it was magic. It's quite magical though, isn't it? And we thought of bringing this magic into our project of non-pyrotechnic separation mechanism. We took the Let It Go challenge to find an alternative to pyrotechnic separation and decided to use this magical magnet in the separation process for the parachute to release without a bang, since magic doesn't always have to be visible.
the problems with the existing models. The most commonly used separator mechanism until now is the light span separator. The light spans have a much complicated manufacturing process and a relatively higher cost. Their large size also results in a higher chance of detachment error. Our grouping came up with the original idea that uses magnets in the separator mechanisms, which has not yet been used in a greater manufacturing process.
Magnetic detachment mechanism consists of two semicircles connected to each side of the cylinder with specially designed movable hinges. Each semicircle contains neodymium magnets of opposite poles. These semicircles form a lid shape on the top of the cylinder, just like a lid of a water bottle. To open the lid for the separation, we use a heating system. We bring the temperature up to 100 degrees Celsius and demagnetize our neodymium magnets. Lids open up immediately as there is no force holding them together, and the parachute is released into the air and the mission is completed with success. Validity. To validate our work, we did some calculations, answered some questions, and figured out that this device would work because the materials used would be able to withstand the given heat range. Our main materials were aluminium and neodymium. Aluminium has a high heat capacity, and this is also the materials that are used in spacecraft. And neodymium with suffix M has a maximum working temperature of 100 degrees Celsius, and it can work also down to minus 150 degrees Celsius with no problem. These magnets have a Curie temperature of 320 degrees Celsius. This is the temperature when the demagnetization is permanent and it would never work again. So the temperature we go up to is quite far from this temperature, so we also wouldn't have to worry about that. The magnets work quite well in space as well because it's just in a vacuum, so that again is no problem for us. Lastly, as the lids are connected to the cylinder with hinges, it will stay connected even when the lids are released and there will be no free debris in the space. All of the above conditions suggest that this device would work.
Advantages. The magnetic detachment mechanism, or MDM, weighs less than a kg. They also don't pollute our beloved space atmosphere. A temperature of 100 degrees Celsius can be withstood by it. The amazing thing about the MDM is its reusability property, which we're sure it will come so handy. And guess what? The MDMs only use an energy of about 20 watts, an energy that is only used for the magnet's detachment. Next slide, please. Impact. As mentioned before, our design is space-friendly. It costs not very much, plus it has a simple reusable mechanism, leaving it costing not much than $20. And finally, the MDMs are non-explosive, meaning they are low shock, ensuring no net debris is left in the outer space. And the last slide.
Materials and finance. We considered many different materials for the cylinder shape, and platinum was the best option, but we decided on aluminium as it costed way less than the platinum, which was quite actually expensive. And we also decided to use neodymium magnets as they're the strongest magnets. They're one of the strongest magnets in our planet. All of these materials added up to around $20, and this is just equivalent to 2 medium pizzas from Domino's. I believe that NASA would fairly be able to buy these 2 pizzas. And since it's been our target market, like space agencies like NASA are also our target market, we hope that this just did it justice. And next slide, please. And this is our hardworking team that designed this project. If you have any questions, we're ready to answer them. Thank you for listening.
Yeah, thanks. I thought that was really interesting. I suppose with it seems really like a really novel idea, but is there like any downsides in terms of when you were doing your research? I mean, I'm not, chemistry or physics and stuff. I mean, I'm computer science background, so I just wonder with the magnets and stuff, where like you know, the extra weight or any kind of like downsides to possibly using magnets.
Hi. So I'd like to answer that question. Actually, very interesting question. That's what we were trying to find out as well, because you know how when you think an idea is too good to be true. So we try to look at things, especially around the magnet itself, and we were worried about its remagnetization phase. But turns out that that would work like flawlessly. The only problem would be that the closest problem would be that it is estimated that a neodymium magnet loses its magnetic property approximately 5% every 100 years. So that's the closest problem we had, that it would eventually lose its magnetism, but that is over a very, very large period. So we did not think that it would be a very serious problem that we would need to address. Apart from that, magnets also lose their magnetic properties at the Curie temperature, which is 350 degrees. But we believe that we would not be going at that temperature in the spacecraft. So that we believe would not be a problem as well. So we did not face any very rigid problems around this.
Okay, thanks. That's interesting.
Okay, so I understand correctly that this is a mechanism, actual physical mechanism that you're proposing, and not an app, not a software app. Yeah?
Yes. Our challenge was to create a mechanism that would let the parachute out of the spacecraft. So essentially, that's what we wanted to do.
Well done, well done. And what do you study in TCD? Do you study
engineering?
Yeah, we are all in the same course. We're studying together. Yes,
right,
in the same class.
Okay. Well done, well done. That's very interesting. Yeah, thank you.
Thank you.
Thank you.
How large a device do you think this could work for? How large a spacecraft?
Sorry, we didn't get your question very clearly. Could you repeat that?
I said, how large a spacecraft do you think this could work for?
Well, we were given the sizes for the cylinder shape, and that was 15 centimeters in length and then 2 centimeters in diameter. And we did all the calculations with this given length.
Yeah. Apart from that, apart from what Fatma just said, this itself is just a mechanism. You can make it bigger because you can create bigger magnets, or you can really, really downsize it. And that, I think, is the most beautiful part about this mechanism, that you can really downsize it or upsize it. And it shouldn't be a problem.
My concern was more that if you're trying to upscale it, that you would have big reliability issues. Because you couldn't be sure that absolutely all of this would work on a larger scale. On a small scale, it's probably fine, but on a larger scale, you would not be able to. It wouldn't be allowed to fly. Okay, because you would not be able to determine the reliability of it.
So
for smaller, it's probably fine. Yeah.
Yeah, to answer that question, that is also something we were worried about, the reliability and validity of the whole thing. And after we did a lot of research, we were able to figure out that there are different grades of neodymium magnets that work for different sort of temperatures, that would demagnetize at different temperatures. And the brief that we were given was that it should hold till temperatures of 80 degrees. So as engineers, we always like to keep a buffer so that, just in case things go out of hand. So we chose to go with the demagnetization of 100 degrees Celsius. So we still have a buffer of 20 degrees Celsius, just in case things don't go as planned.
The problem is being able to achieve those temperatures reliably. You're not sure that you'll be able to get those temperatures exactly right in space. So that's why you have to have a certain buffer.
For that, we would have a heating system inside the spacecraft that would heat the magnets to demagnetize them.
sorry, I want to add something that to that as well. Yes, the temperatures, obviously it would be tricky to get it at the right temperature. You're right about that, but it takes only up to like 0.35 seconds to go to the desired temperature. When we did our calculations, we found out that. So it's not that like when it just reaches the maximum working temperature of the neodymium magnet, it will stop working. So it will do what we ask. Even if it goes over the temperature limit, it will still do what we've asked. And also the weight wise, they told us in the challenge that it had to weigh less than 1 kg. So we just did all our calculations by that. But like Kuvesh said, that we can obviously change our calculations and alter it for a bigger device, and it might work or it mightn't. We would have to do more research on that, of course. That's for sure.
I think at the end of the day, it's all about research and experimenting. And we've done the research part, and unfortunately in these 48 hours we have not been able to come about to experimenting, but I think we'd love to actually try that and see how it works.
Okay, thank you.
Would you have any other questions?
Okay, I think the time's also a critical element over here. So this was great. Again, congratulations on the presentation and good job. Let's move on to the next team quickly, which is team number 6, and that's called Team S. And the members are Osobi and Ryan Morrissey. I hope they're on the call. Let me check. Yeah, Osobi is there on the call. Osobi, whenever you're ready, you can share your screen.
Yeah, can you hear me?
Yes, all right. You can share your screen, and whenever you're ready, we can start the timer.
Okay. So hi, my name is Asubi. My teammates are Ryan Morrissey and Evan Hawks. And we're working on the project named Unlocking the Secrets of the Sun. Now, your challenge is to develop a method to improve public awareness and understanding of these spacecraft and how the valuable data they provide impacts the way we live, work, and our approach is to spread awareness by making a website, by gathering data provided by spacecraft that observe the sun, and we also research information on data collected by solar spacecrafts. We plan to give our readers a deeper understanding of the sun and why it's important to know all these details about the sun, which way it could potentially affect human life. One of the main reasons it could affect human life is by finding a new the fossil fuels are finishing and we need to find alternatives soon, like sun rays or one way, but solar winds are also a different one. So our main users would be scientists, researchers, and students. And our potential partners would be space explorers or energy companies. And like I said before, you can use solar wind as a different energy source. So it will be very beneficial for companies up with us. And who will be affected? That would be anyone at all could be affected because we'll be using a different source of energy. And our screen, we made like different pages. And we also have one page that shows all our resources and where we got our and our planned features for future development are a quiz to engage the users so that they get an understanding of the level they're at or how much they understand about the sun, or you can also take part in it just for fun. And another one you want to add is a form so that you can ask questions and you answer them. And the main reason we didn't have them on the website at this moment is because of the lack of time. and we were focusing more on gathering information about this. And that's it for your time.
Okay, so if you're done, then if you're ready for questions, then the judges can ask questions.
Yeah, you can ask questions.
Do you want to go ahead, Nick?
Yeah. So you're planning a website with a forum, and is it this? Did I understand correctly?
Sorry.
So can you please repeat what will be the outcome of what your proposal?
Basically, we're just making an educational that gives the user an understanding on the sun and in what way we can use the information gathered by spacecrafts that observe the sun.
Okay.
And in which way.
Yeah, your audio is breaking from time to time. Maybe. Yeah. If you switch off the camera, might be better.
Yeah, maybe.
Yeah. Okay. So that's another educational project about the sun.
Yeah.
I'm good, James. If you want to ask a question.
Yeah, I suppose a quick question. What would you say was the most challenging aspect when you were developing it?
The most challenging aspect would be trying to make the quiz because we actually started it, but it wasn't completed. So we gave up on that because we didn't get it to work. But other than that, it was relatively easy to do because I had two team members, so we could split up the work and work faster.
Okay, thanks.
Yeah.
Okay, so that was great, Osobi, and good job. Let's move on to the next team, and I think that's the last team for today. That's team number 7, and Prasad Netsure from Westworld is going to present a challenge. You are my sunshine. So that's the challenge name. And Prasad, whenever you're ready, you can share your screen and you can tell us so that we can start the timer. I think you're there on the call.
Yeah.
Yeah,
Hey,
great.
hi, Sahir. Hello, everyone. So my challenge is related to like my team name is Westworld, and I'm the only person who is in this team. So my challenge is You Are My Sunshine. So it's actually developing a mobile app which can be used to know the sunshine data. Um, as of today, like NASA has a website called as NASA Power. Yeah, NASA Power LARC, where they are where they are providing different endpoints to gather information about the sunshine. So using this information, we have to provide certain graphical representations to the end user on the mobile app, and we also have to allow the user to provide inputs, like in case the user is authenticated to do so, like suppose the sunshine data value is 1 and user wants to input some different value, and the source is authenticate, like it's not a general public, but it is some person who is more concerned about the data and can provide the relevant data. So even this app would be like take considering those inputs as well from the user. So the requirements were like as of today, solar irradiance or sunshine, it is not readily available on any app for general public, but it can be accessed via NASA Power Web Services portal. So as I mentioned, there is a website on NASA Power which has that API, and we have to send that data to app to any end user via a mobile app. so that they can use the data for their particular purpose, like to analyze how much sunshine would be there in their area. um, so who will be benefiting, like who will be the end users? So there we can categorize the end users or customers into different types. Like some of them would can be a homeowners, like basically who are buying some equipment, solar panels or any solar devices, and they wish to know whether they are getting any return on investment. So they will be like they would like to know that whether sunshine, how much sunshine they would get in their area. So it can be used to generate electricity and various other purposes. So even some environmentalist or solar enthusiast people, they would like to get some information. So basically, the environmentalists would like to know if non-renewable energy sources are uh, saved and we can move to renewable, like solar. And it can be of interest to some business person or technologist or any energy companies. So yeah, so basically the approach and USPs and features. So here the application which I'm trying to make, it is an microservices application. So I will be exposing like 2 or 3 endpoints or 2 or 3 services, which would help me to so like which would be used by the mobile application. So it would be very lightweight, like since it's a microservice architecture, the mobile application would just be hitting the endpoints in my service, and it would be trying to get the different data related to sunshine. So the main point, it would be like very low network calls. I can explain it later why it would be very low network calls. But the application would be robust, it would be extensible, and it could be scalable. Like it can be used for even if like the requirement is more, we can always scale it. So the final product, yeah. So final product would be like we would have some microservices. The first one would be a scheduler. So that the scheduler was the reason why, I was saying, there would be very low network calls to a NASA Power website. So a scheduler would be scraping or would be collecting the data from this portal on an hourly basis, since the API is providing hourly data. So it will be doing it for few locations. So locations would be based on completely based on the analytics. Like currently my application which I have developed is just scraping for Limerick area, but it will be scraping those data and it will be storing it inside a MongoDB, which can be also used for like in future to understand the traffic. But there would be another endpoint which would be exposing this data, and it would be utilized by the mobile application. So the a mobile application would directly query this data, query this service, and it would get the data for monthly, like different time durations, like monthly, yearly, or on a quarterly basis, or even for a day on an hour basis. So this is like my pattern, like how the final product would look like there would be 2 3 services. Like the one would be for querying this data, and the another would be for even to collect the sunshine data from authorized users. Like as I mentioned, there would be some users some energy companies or some some people who are like solar enthusiasts. They would know maybe they can calculate the exact value, so they can provide that as an input, and it can be utilized to correct the errors and even for analysis. And then the future possibilities, as I mentioned it, right now I'm not focusing on business and data analytics part, but it can definitely be used to do some analytics for sunshine data, and it can even promote tourism. Like there are certain people who would like to visit a place, like I can say about Ireland, it has a very unpredictable climate. So when there can be a sunshine, no one can guarantee, but if you can just use this data and promote tourism, it would be helpful. And even it can be integrated with solar devices or any third party integrations, like those who are really benefiting from this information related to sunshine. And I have not developed the Android application as such, but this would be how it would look like. It's just a proto, like I have not completely finalized it. Like it would be sunshine, and the on the x-axis it would be the time. Like I can check daily, weekly, monthly, yearly. I can get all options. If it's based on hours, I can even scale the entire graph, so something like that, and I can get user input from certain users who will provide me the value for that sunshine. And yeah, and I can show like what exactly I've done. I have saved the, like I have generated this application which is currently collecting the data for Limerick location, and once I run it, it is sorry. Yeah, once I run it, it is actually there is a scheduler. Currently it is running for like one minute, every 1 minute, but it would be configured in future based on the API support. So like this scheduler is will be just they collecting the data and will be putting it into MongoDB. So once that is done, we can, like any mobile application can just, okay, there is no collection yet. Yeah, so it has begun downloading the I used a CSV format here, but it will persist all these sunshine related data in the database. So it's a non-relational database, in it can scale again in as its document, and I can just view this data here. So I have given 1st April 2021, so 24 hours. So I'm getting hourly data like year, month, day, hour. So if someone wants to plot a graph for a particular day, he can use this data. And I'm still on the like track to prepare an Android application for the same, which will be utilizing this service, and it will be plotting a graph. So apart from that, there would be some user input, like basically if someone from a particular location, someone wants to give an input to change this value, like for 0 hours at 12 o'clock, it won't be at night more than 0, but still they can give that input and suggest some changes as well. So yeah, that's it.
Okay, so that was great, Prasad. Like the judges can ask you questions if
Yeah.
we have a minute or two.
Yeah, sure.
Yeah. Sorry, I didn't get the name of the team.
It is like Westworld, like I have named it Westworld.
Sorry,
I'll add it.
Sorry, what is the name of the team?
Westworld.
Westworld.
Ah, Westworld. Yeah, Westworld. Okay, okay. Sorry about this. Yeah. Okay. So James, do you want to start or can I go ahead?
No, you go ahead. You go ahead, Nick.
Okay. Prasad, the data that you are collecting about the sunshine, is this freely provided by NASA?
Yes.
Okay, and NASA doesn't have a tool, doesn't have a similar tool
It
to
doesn't have a mobile application for the same.
They have a web application.
Yeah, it's just a web service they have exposed right now.
Okay, but not an app. So the value of your work could be of this project could be that you are providing a mobile app for this.
Yeah.
Okay.
But I'm trying to, yeah. So in order to prevent more frequent calls to NASA, I have developed this backend as well, where I'm exposing my own web services. And yeah, so I'm just like I've not developed Android apps in the past, so I'm just doing it on. In the process. Maybe today I will finish it.
Yeah. I mean, yeah, that's a good idea in general. Yeah. I mean, yeah, that's good. Yeah, James, if you want to ask something.
Yeah, just one, I suppose, quick question. In terms of actually the development of the app, I know you said you didn't get a chance to do it. I mean, I suppose it is a big undertaking with just a team of one. But was that something you were aware of when you started, or was it something you kind of realized shortly? Like, did you start out with an initial plan that you were going to develop the app, or was it just going to be the design for an app?
Like when I started, I'm actually a housemate of Sai, so he explained to me what the challenge is exactly. So I just, when I started with, I was not having any prior experience with Android, so I've started learning it. But since I'm already having experience with Java and Spring Boot, so I just developed the design, like how it would be looking like based on my previous projects I have worked on in my last companies. And um, like I focused on making sure that I'm like covering all domains like analytics as well, because this data can be really useful for other integrations, as like if some tourism or some flight companies are interested to know this data, so definitely they would like to they would like to have some analytics. So that's why I just came up with this design.
Okay, cool, that's good, thanks.
Yeah.
Okay, so that was great, Prasad, and let's move to the next team, which is, let me share my screen. Let's see which the next team is. The UL Badger. So Timothy Hannon, I hope you're on the call. I think you were there. Yep, great. So whenever you're ready, you can start sharing your screen. Timothy, can you can you hear? And I think you're muted. You're still mute. Okay, so I'm not sure if there might be a technical problem, so we might come back to Timothy after the last team. There's one more team over here, Amber. If you're on the call, these are the last two teams which sent in a last confirmation. Whenever you're ready, you can share your screen, Amber. Okay, so these were the last two teams, and it's a final call. If you want to present, you can present now. And now we'll deliberate for the judges' discussion. If these teams are not presenting, it's a last call out. I think you're there on the call, but it's fine if you're not ready with the projects. You can pop in the chat if you can hear me, or if there's any issue. But mostly, if it's not the case, we'll move on to any other teams who want to present. If there are any other teams, they can take the stage right now and take this last opportunity to present. Okay, great. So if there are no other teams, then we will go on to the deciding the results, which we're excited about. This is something which we have been excited about throughout the 3 days. Who's going to get the winning prizes? These are the three winning prizes. You can consider them as first, second, third, but there's no one who's first, second, third. Everyone is a winner. Everyone who's presented your projects today, everyone is a winner. You've ended up developing and creating your project for 48 hours, and that's a huge task. So in my opinion, everyone is a winner, whoever has participated in this competition. And these are the three prizes which are being given. And this is specifically given by NASA. It's not related to a location. So stellar local lead is the first prize at a specific location. Galactic problem solver is the second prize at this specific location, and galactic team member is the third prize. So we can say that the stellar local lead is basically the star performer, and galactic problem solver is the best solution provider. And the galactic team member can also be is basically the strongest virtual backbone, or uh, the third prize, which could not perform in related to the first or the second ones, but definitely deserves to be up there. So these are the categories, and now we need to evaluate, and the judges can break off from yeah, no problem, Amber. That's fine. Next year and next time, that's not an issue. But evaluation now. So the judges can break off, and I'll just set up a breakout room, and I'll add manually so that we can talk and deliberate. And we'll be back in like 5 to 10 minutes. think there are questions. You can. Oh yeah. James has a question.
No, I was just going to say, I think Sahir, there was a question from someone about the judging. I think I saw something pop up.
Let me see.
I thought I saw a question from Craig. Was it?
Yep. There's a question. Okay, so this is a general doubt that because challenges are very different. Some students might be confused about judging, or some participants might be confused about judging. But the judging criterias are very generic. The judging criterias are not challenge specific, and they've been given by NASA. These are the 5 categories. They're not So it's a very generic judging criteria, and this is a standardized criteria. So like if there is any specific doubt on judging how it's taking place, we can go through that once judging is done and the deliberation is done. So for now, I'll just break off into the rooms and we'll be back in like 5 minutes. So I'll just create the rooms. It might take a minute or two. Okay, so hi everyone. I hope I'm audible. I'm back. Who's excited?
Welcome back, Sahir.
Hi. Hi everyone. Okay, so we have that room open. They're over there. They're discussing. They've discussed and they've mostly decided with the results. So who is there on the chat? Let me see. Okay. Yeah, I see many people. I see the winners. I'll not tell right now. I'll probably share my screen and then that will be better. So okay, I think James is still in the breakout room. I'll need to close the breakout rooms first, and then we can start with the session. Okay, so I see James is back. James, I hope you're back.
Yeah, I'm back. Sorry, I thought I'd been abandoned in the breakout room. I was worried. So.
No, really sorry for that. Okay, everyone is back, and okay, so now it's time. Now it's time to announce the results. Okay, and is everyone excited? Who's excited for the results? There's no one active, no one excited. I feel there's no one excited. Yep. Okay, one person is excited. Okay, so there's only one person in the whole chat who's excited for the results. Wow, great guys. Okay. Okay, let's just show it then. And the results for NASA Space Apps Limerick 2021. The time has come. The stellar local lead is Lua Lipa +1. The galactic problem solver is Space Bean Hunters. And galactic team member is TCD team. Congratulations, everyone. Well deserved. Amazing. That's amazing. And okay, so you might have some queries, maybe. You might have some post hackathons information, something I need to convey before you go and congratulate yourselves or go and party. So the post hackathon progress, there is something which is very important for all the winners right now. Following 1 week, there'll be a hackathon, post hackathon progress. You'll be working on your projects and then you'll be submitting. On 10th of October, you will be making a global submission. And this is the next level. This is the international level where each team is going to take part. And from different locations, all the winner teams are going to take part at the global level. NASA Earth Science Division will have a lot of judges, and they'll be judging that global process. They'll be looking at your source code, which you'll be uploading on GitHub, and they'll be going through a whole lot of elaborate documentation. You'll also be asked to prepare a 30 seconds video, which will go up on the website. So that's the post hackathon work which you have to do after winning. It's not just about resting and partying. It's about thinking for the next level, which is the global nomination process. And if there is any help which is needed, I am there. Okay, you can contact me anytime. My team is there. Everyone is there. The mentors are there. They'll be very happy for you to win the global event, and I feel that you should take that advantage. Take this 1 week and prepare a lot of these things. We'll be sending an email out soon for these details. So, okay, so lastly, this is something which I wanted to do. This is my vote of thanks, because this is something which was not possible without many of the agencies, many of the global collaborators which we have. A very welcome and a very thanks. This hackathon would not have been successful if not for the support and contribution of these certain organizations and individuals. Like, firstly, I'd like to thank NASA Space Apps for creating this epic challenge hackathon with all its thrilling 27 and 28 challenges. I would also like to mention the 9 partnering space agencies and the global space apps collaborators for this year: Australian Space Agency, Canadian Space Agency, Brazilian Space Agency, the European Space Agency, JAXA, the Argentinian Space Agency, and the Paraguayan Space Agency, along with the South African agency. So all of these are global collaborators, along with Google, IBM, Meteomatics, Adobe XD, GoDaddy, and Planet. These are some of our global collaborators, and this mission is led by NASA. Okay, so a very warm thank you to the host institution, University of Limerick, and the Department of Computer Science, Dr. James Patton, Dr. Nikolov, and Professor Mike Hinchy. They're representatives of this department, and without them, this wouldn't have been possible. LIT, which has recently become TU Shannon, they're our official academic partner. It was being like there were teams who were participating from this institution, and we had many mentors, and we I want to thank them personally. I couldn't express my gratitude enough, and I want to thank them, all of them. Raghav Dikshit, who's an expert at product management; Dr. Nikolov, who's not there in this picture but has been available as a mentor for the teams; and Jonathan Chesney, who's the director of product management at HubSpot. We had Utkarsh Srivastava, who was the senior consultant at Cisco. And then we had Arvind Kannan, who was who works as a designer for Google, and he helped out many of the participants. And then we had Anurag Priyadarshini, who's the founder and lead at Urban AI. We had many mentors. We thank you warmly, and the judges as well. Okay, so lastly, this event would not have been possible without our participants. I thank you all for your enthusiasm and your strenuous effort put into over the last 48 hours. Last but not the least, I would like to thank to the volunteer team. There are people who did organize this and help me organize this, and without the support of these volunteers, this wouldn't have been possible. Beginning from the planning, outreach, marketing, to tech support, to conveying this to the participants, designing these things, communications and operations, everything was done by this team. Your hard work over the last 6 odd weeks has definitely paid off. Thank you. Thank you to all the attendees, well-wishers and supporters, especially those I have not been able to explicitly name here. We hope to make a greater comeback next year. Our aim was not to spread, our main aim was to spread the hackathon culture in Ireland. And I hope like we made an effort in achieving that to a certain extent. Let's keep this momentum going, and let us all continue to create, innovate, and collaborate to make a difference. Thank you and good evening.
Thank you.
Thank you, Sahir. Well done for organizing this event.
Thank you, Sahir. It was a great pleasure to participate as a mentor in this program, and I would seriously await for the next year. And I see a lot of enthusiasm in the participants, as well as all the mentors and the leaders like you and all the judges. It was a pleasure seeing that how this young talent is working towards solving the problems of the future. It was a wonderful event, I would say.
Thank you so much. Thanks a lot. And it was not possible without you guys. Honestly, my thank you was, I meant it from my heart. Honestly, thank you so much. Okay, so that marks the end of our whole closing ceremony. And after thank you, I would just like to tell that next year Space Apps is happening, and it will happen in Ireland at a very large scale. We will will do this, we will grow this community, and the hacking community will spread here. So that marks the end of it, and I will see you guys next year. Bye bye.
Thank you. Bye.
Yes, sir. I'll break us into a room. Yep. And everyone else, thank you so much for attending. We will get an intimation soon on what are the next steps. That's great. Congratulations again.